we talked about exponentials not that long ago, and now we're talking about logarithms. The relationship between the two is that they are inverses of each other, and we've seen inverse equations before, back in like early February-ish. And if you remember, what happens with inverses is that our x's and y's switch places, which in turn means our graph is a reflection over the line y equals x. So the difference between these graphs and the ones that we've been working with is that these are going to have a vertical asymptote, whereas our others had a horizontal asymptote. And again, that's switching because our x and y values are switching. Are we good? Do we have all this written down? Yes? Okay. So let's flip to the back, and we're going to do two problems together. Before I even start this problem, I'm going to rewrite it because it's going to be easier for me to type in like this. So I'm going to put the +4 out front. Like I said, it will be easier for me to type. I'm also going to add the word asymptote because I always forget that. All right. Now, this one you have to get to in a weird way, so you're going to have to follow along here. So I'm going to type in my 4. I'm going to type in my plus. Do we all have the 4 and the plus? Mm-hmm. Okay, so type in your 4, type in your plus. Do you see down here where there's a little keyboard icon thing? Mm-hmm. Click Show Keyboard. Then, you see all the way over here there's something that says Functions. Click on Functions. And then scroll on down. I know. Scroll down till you see log base A. So we don't want this log, because you see where it says just log, that's going to give you log base 10. We want log base A so we can put in whatever base we want. So click on log base A under calculus. So you can say, hey, I was doing some calculus today, guys, after the PSAT. All right. Do you see how it popped up so that now I can type in my my base? So type a 3 and then arrow to the right until you're inside the parenthesis and type an X and close it. How do we do? Do we have it?
Yes.
Lovely. Perfect. Okay. Have functions. Scroll down to where you see calculus. 2 functions. Up. Here. Yes. Good. Type in your base first. Go down there. Yeah. Type in the 3 and then type in the X. Okay. We know how to graph at this point, right? Find some points. I don't care if they're nice. I don't care if they're ugly. I'm going to find 3 points. I'm going to put them in a table. Let's see. I've got 0.01, comma 0. That's going to be the first point that I pick. I'm going to pick another point. Ooh, who are you? Are you 1 and 4? That's what I was just looking for. 1 and 4. And then 3 and 5. Yep, that makes sense that 3 and 5 would be another one. Okay, so we found some good points. And you will be able to on these. Unlike the ones that had E in them, where we had one good point and the rest was just kind of mayhem in terms of what they were. Okay, 0.01, comma 0, 1, comma 4, 3, 5. All right. So the next thing that I want to do is go ahead and plot these points. So I'm over barely anything and I'm at 0. I'm over 1 and I'm up 1, 2, 3, 4. I'm over 1, 2, 3 and I'm up 1, 2, 3, 4, 5. Yes, bless you. Okay, now, don't draw it in yet. If you already did, that's fine. But here's why I want to warn you. there is an asymptote just like there was with the other graphs. And I'm going to draw it in so it's a boundary line that I don't touch or cross. Because remember, that's what an asymptote is. So my boundary line is always going to live at the y-axis unless I have a shift left or right. So that
-1 or 0 still?
It's going to be 0. Yeah. So I'll show you how to look for when it switches. If you don't have anything shifting it left or right, it's going to stay right here with the asymptote at the y-axis. So let's look at our domain. Do I have any graph over here?
No.
So look, no graph, no graph, no graph, no graph,
Graph.
no graph. Where do I hit graph? Beyond what?
The Y.
The y. And in terms, so I'm going to say my x values have to stay greater than 0.
Oh, so it's not all real numbers?
It's not all real numbers because does anything live over here?
Nope.
Nope, nobody's home. So no graph, and I don't even get to 0. So that's why this is just greater than 0. It's not
Word.
greater than or equal to because it'll never get to 0.
Word.
Now look at your range though. This is going to go down forever and ever. So is that going to hit all our negative numbers?
Yes.
This is going to continue to go up and over. Am I going to hit all my positive numbers?
Yes.
Yes. So the range for these is always all real numbers. So it kind of flip-flops from what we saw with the exponentials because they're inverses of each other.
So what about your asymptote?
So my asymptote lives at what? At 0.
Yeah, so would it be equal to 0?
Mm-hmm. But
Is the x equal to 0?
it sure is. I love you thinking through this. So the asymptote is x equals 0 because it's vertical instead of horizontal.
Word.
So y
Word.
equals when it's horizontal, x equals when it's vertical.
Word.
Okay, let's do one more together, just to make sure we've got it, and then I will only make you do 2 on the worksheet. Yes, I know you're burnt out. Yes, I know you tested all morning. All right, here we go. Add the word asymptote in for me, please. Whoops. Well, that's a terrible table, but we'll go with it. All right. So next one. I don't want anything out front, so I'm going to just backtrack out of that whole thing. And I'm going to go to my functions button. And I'm going to go down to calculus. Log base A. In place of the A, I'm going to type a 4. And then I'm going to arrow up and to the right until I'm inside that parentheses. And I'm going to type in x minus 1. So anytime you have something in parentheses with x, it's going to shift it left or right. And when it shifts it left or right, it has kind of this push-pull impact on your asymptote. So this asymptote is going to be in a new spot. Where does it look like your asymptote is? What point is it never going to touch or cross?
0. Got it.
I won't touch or cross 0, but also, do you see how it's getting real close to 1?
Oh, yeah, 1.
But it's never going to touch or cross 1. So let's go ahead and start with that information.
Wait, I got 1.003.
Right, because it can get real close to 1. It can get 1.003. It can get 0.003 close to 1, but it can't ever be 1. You found some good points? All right, I'm going to steal Leo's points in a second.
Bro, take me out.
No, you've got this. Okay, so here is my asymptote at 1. It's never going to touch or cross 1, but it's going to get super duper close. Leo, tell me some good points.
2, 0.
2, 0.
5, 1.
5, 1.
9, 1.5.
9 and 1.5. Whoop, whoop. Okay. All right, so let's go 1, 2, 3, 4, 5, up 1, 6, 7, 8, 9, up 1.5. All right. I'm not going to touch or cross my asymptote. I'm going up and over. So that's how they should always, always look. Okay, domain. Let's look in terms of left to right. Do I have any graph over here?
No.
Not so much here, right? Where does it start? in terms of domain, my x values are all bigger than what?
1.
Than 1. Remember we talked about before that the asymptote and the value in part of my domain and range, like they're going to be the same. They're going to be a match. And then the range, is this going to go up and hit everything? And down and hit everything? So it's all real numbers for this part. Okay? So the only time this number changes from 0 is if you have a parenthesis and inside it you have addition or subtraction. That's going to be what moves your asymptote. Otherwise, it's going to be at 0 every single time.
Word.